Hey, folks. How's it going? What's up? Come on in. Grab a seat. Today we have a treat in store. Let's see. Getting everything set up. All right. So what are we doing today? You ask, curious, but also somewhat hesitant, wondering. How serious can it be? How cool can it be? Well, dear viewer, I'll tell you. Today we're going to write some software in jank. We're not going to work on jank itself unless we find some bugs that we want to fix immediately. But I actually just want to write some example applications in jank that I hope are going to end up just going into the jank repo as examples that are full projects, Lanigan projects that are going to run from Lanigan, as well as be able to compile down to standalone executables. And so this is going to be something that we're going to be doing more than just today. We're not going to hit all the examples that I want to be able to ultimately tackle, but we're going to start on that today. And I'm expecting that we're going to find some bugs. And so I should probably say bugs, maybe just issues, because I would consider something, like a poor UX on something is maybe not a bug, but it's an issue I want to call out. So we're going to do this in order to get some examples that we're going to have in the jank repo, but we're also going to do this in order to dog food, which is to, if you're not familiar with the term, is to eat your own dog food, to swallow what you're making other people swallow. And I think nobody's really using the whole Lanigan setup right now, because nobody's just building project-based jank apps right now. And so, yeah, we should get some more testing done for that. And in the best case scenario, this goes as just a really great demonstration of exactly everything that jank can do. With no issues at all. But realistically, we're going to find some issues. And we're going to note those issues down, and then I'm going to fucking fix them. Probably not on stream, but I'm going to fix them. Now, all this comes because, all of this comes today because it is my goal to get jank into your hands as soon as possible. So we'll talk a little bit more about that further into the stream, but I really just want to stop developing like in a bubble, of just me thinking about what jank needs. And I want to just get people using jank, and then I want to work on whatever they need. So that involves showing people, what jank can do, and then making sure we have good documentation, good examples, so that people whose risk profile matches where jank is, which is, alpha software, but software that you could definitely build things with, that they can get going. And at that point, any sort of friction blockers that they hit those are going to be the most important things for me to tackle. So strap in, sit back, and let's jump into this. So to start with, I want to write a command line application. We might even do multiple command line applications. It's really tough to come up with examples. Like, you want them to be interesting enough, but you also want them to be easy enough to digest. It's like this really fine line to tread. And it's nice to bring in some C++ stuff because that's obviously what jank does. But we don't want to get bogged down by it. Yeah. So if you come up with examples, if you have any ideas for examples, let me know. This first example, so let's do this. I have not tried this at all. I'm going in blind here, aside from the fact that I wrote jank. But aside from that, blind. And so yeah, I don't know what issues are going to hit. But if you come up with any other examples for these things, I think maybe we'll do like a dear imgui there, and maybe SDL. Those kind of overlap a lot. What if we could do instead of, so imgui is a good one. What if we could also do like an actual native desktop application using like a GTK plus or Qt? Qt has its own like meta object compiler and everything. So like, I don't know how that would go in terms of C++ interop, but GTK plus should be fine. Yeah, the only native desktop application development I've done is like GUI is Qt for Linux, that is. Windows obviously has its own dealio. Okay, so like I don't even know how to start a new project here. I think we're gonna need to boot up the browser, and we're gonna need to go to the jank book, and we're gonna need to take a look at what's up. So hello line again. We already have line again. So we can do this. We can do this guy. We're gonna do this guy here. So we're gonna do a new with the jank template, and then what we're gonna call this is weird JSON query. Let's do that. JSON query. JSON query. And I actually want to put this into a CLI directory as well, because I'm gonna move JSON query into CLI. Hey, Rebel Elder, how's it going? Okay, so at this point we have a simple application. If we open up the source, we have a main file that has a main function in it that just does a print line. So we should just be able to do a line run and see our hello world here. And we do. And we should, actually, I don't even know if I have a release version of jank right now. I do. Okay. This also, I love this health check that jank has. So nice. One thing I don't have that I want to add is just the CMake configuration that was used to build jank here. Why not do that? Yeah. And since we're noting things down here, let's just note this down. So add CMake, I don't even remember what it's called right now. release build type to health check. And yeah, so we would need to export that inside of the CMake files so that it becomes a preprocessor defined for jank. And then we can print it out inside of the health check. That's fine. I don't want to worry about that right now though. Moving on. So we should be able to do a line compile in order to, and this just merged. So we're on main. I just merged this today. Let's take a look. Nice. Nice. So 26 milliseconds. And if we take a look at our, binary, you notice we're not linking to Clang. We're not linking to LLVM. So we have a statically, it's not statically linked, but it's a jank static runtime application. And then we have statically linked jank inside of it, which is why we don't see anything like that here. The only dynamically linked libs that we have are system libs. So like libc, we have a C++ standard library, and then math, and then some compression shit that we use. I'd like to get rid of these, honestly, but they're a transient dependency of one of our other dependencies. We'll see what we can do. We'll see what we can do. But also, this is unstripped. If we strip this, then we're down to 9, which is quite a bit smaller than the Graal VM native image. That would be 15 megs for the same thing. So that's a win. Already super easy to do, and also smaller than Graal native image. But this is just a hello world. We haven't actually written our application yet. But we have tested that all of this works, and I'm pleased so far. Everything's going swimmingly. So let us open up our main here. Now, what I want to do is I want this program to behave similar to JQ. Obviously, we're not going to implement all of JQ. But what I want us to do is, I'm actually just going to open this over here, and example JSON query main. And what I want to be able to do is something like, also, can we like, don't name the file a.out by default anymore. That's something Clang does by default, and so we just sort of stuck with it. But we should just, I mean, we have a little project set up. We should just name the file by default to be the name of the project. So in that case, it would be called like JSON query. I think that would be preferable. Don't you think that would be preferable? Yes, you think that would be preferable. Okay, so what I want to be able to do is something like, I want to give it a file. So like foo.json, and it's going to read that file in. And then I want to be able to dig into that file. Eden query would be nice. Maybe bias is showing though. That's a fair point, Rebel Elder, but I did consider this as well. But the thing is that jank already just has Eden reading built in, right? So we could just do a read stir, and then that's very easy. And I wanted to do JSON because I wanted to bring in a C++ library and show what it's like to bring in like a header-only C++ library and just add it to your jank project and just have that work. And so that's why I'm thinking JSON. But I do hear you. You know, like realistically, one should be choosing Eden if one can. So there's this JSON lib, and also let me silence my Slack so that you guys don't here, there we go. There's this JSON. I never remember what it's called because it's, yeah, an N-Loman JSON. But I just remember it's JSON for modern C++. Anyway, this is like the #1 JSON lib in C++. It's got 50,000 stars, and those aren't just like bot things. This thing's been around a long time. It's very proven. It's a very proven sort of library. And it's also, as is the like common practice for C++ libraries, it's header only. And so that means that we don't need to link to some sort of precompiled library or something like that. There's no like static library or shared library that we need. All we need to do is include the header or headers for this, and that's all. And everything is available. So the release assets here, we actually just have this JSON.hpp, which is about a meg of C++ code. Is transit an option? No, I think for the same reason as just reading Eden, like I'm trying to demonstrate C++ stuff here. And I don't know of a C++ transit library. And also, like in terms of simple examples, I think people are a lot less familiar. Like transit is a lot less common. People are less familiar with transit. Okay, so we have this. I don't actually know where that went. So let's. Did that go to JSON.hpp? Did that go to downloads JSON.hpp? Where the show in folder? Oh, I don't know. I don't know where this is gonna go. And I don't want to like just reveal everything that's on my file system. You guys don't know what I'm up to. All of my secrets will be revealed. All right, give me a moment. Let's see. We'll go black screen. I don't know where. Okay. So Chromium puts it into. Chromium puts it into downloads with a big D. Okay. So if we move this here, if we look inside of source, I'm going to make a libdir, and I'm going to put JSON.hpp inside of there. And then what we're going to want to do is, so the other reason why this JSON example is not, why it could be better, is because ultimately jank should just have like a closure data JSON implementation, where someone will just require that namespace and then they'll be able to read JSON that way. We don't have that right now, but yeah, I mean, as I said earlier, if you have other ideas for examples, then let me know, because coming up with examples that are complicated enough to be interesting and simple enough to be easy to understand is like surprisingly and incredibly difficult. Spent all morning thinking about this, and I'm still not pleased with what I came up with. Okay, so let's see. Here's an example of how we use it. All right, so we got to include the header. Then there's this, bro actually used his like last name as the namespace. And then there's JSON inside of there. So what we want to do here is inside of our jank file, we just want to do a pound include. And so we have this JSON.hpp, right? Now, if we jump back in here and we try to line run, it's not going to fly. And so we're gonna say, okay, I don't. Clang is going to give us this error. I don't know how to include this thing. And so jank actually says, okay, yeah, unable to compile some C++ stuff. And this is because we don't, like on the jank side, we don't actually check for includes ourselves. Maybe we will in the future, but for now we just rely on Clang to do that. And the problem here is that we just haven't set up our project yet. We haven't set up our project to look inside of this libdir for headers. And so let's do that. I need to refer to the jank book again because I don't remember how to do that. Bring in native libraries. Where do we do this? Compiling. I remember I have an example of these are test paths. Compiling. Hey, Mohammed. I think this is the one. Yeah, it's the one. So we just have include dirs, library dirs, and linked libraries. So we just want to do include dirs lib. So now we should just be able to do a line run, and we'll see our hello world. So we see this warning that the target directory is being cleaned because the configuration has changed. And this is great because that's true. We added a new command line. We added a new include directory. And so any of our pre-compiled object files have been wiped out because the entire like global build configuration has changed, and they're out of date. And so that was cleaned for us, and now we're still able to print hello world, so we're good. That's our include. We don't yet have LSP to tell us that this is totes Magots okay, but it is. And now we just need to actually use this. So let's see. There is, so here's the include. Now we're gonna bother with this alias shit because that doesn't matter. Mainly, it boils down to if you have an input file stream, which is an if stream, so C++ object, then you can call JSON parse to get back a JSON object. Let's do that. So I'm going to bring in a let. So we're going to expect some arguments. The first argument is going to be the file. And so let's just say file. Let's not worry about validating these input arguments right now. I don't even know if we're going to. And then let's say that the path that we're gonna query into. Well, we'll call this query, since this is JSON query after all. Is this? We're not gonna do anything about this just yet. So now let's do our JSON stuff. So we're going to, and again, we're going to need to open up a file stream first. And then we're going to call JSON parse. Let's call this if stream. So we're going to create a C++ if stream. And what we're going to do is we're going to give it some string file path. And what we have here is just this file. And file is just a type erased jank object. We don't know what that, we don't know what it is. We just know it's a jank object because it's a result of calling first on some jank sequence. So if we do this on its own, this should not work, because this constructor call is going to be ambiguous, I would imagine. Oh, interesting. So we looks like we try to instantiate it, but then we fail. So I expected this to fail, but I did not expect it to fail in this way. This is failing still during analysis. Okay. So let's note this down. So what we did was this. Now, what we should be able to do to fix this is cast this to a standard string. Oh, nice. So we've found some sort of template instantiation bug. Curious. What if we did, I wonder, a C string literal here, and we just did we just did a foo.json. Also, we don't have a foo.json. Let's add one of those. Okay, I know what's going on. Oh, hey, Kyle, how's it going, man? I believe the issue here let's see if I'm right. I believe the issue is that we need fstream. It is. So this is a tricksy one, right? Because the error here is correct, but this is just one of those C++ things. So basically what happened was we had a forward declaration of standard if stream from somewhere. Maybe it came from JSON.hpp. Maybe it came from some of the jank headers, but we didn't have the definition of the actual template. And so here, when we tried to construct this standard if stream, the jank analyzer tried to instantiate it because it's a template, and it failed. And it failed because there's this implicit instantiation of an undefined template. And there's not really anything that we can do there because it is undefined. And the only thing we can do is like try to instantiate it. Yeah. This is one of those like C++ problems where this just kind of bleeds through, and I don't really know if there's any sort of improved error message that we can provide. But anyway, with the correct include, if we specify file, now this should fail, back to the failure I was expecting, because file is a jank object. And here we're going to try to construct the if stream with a jank object, and what we're going to see is that, yeah, so there's no normal overload match that was found for all of the if stream constructors. And just so you guys have the mental model of this, let's take a look at what constructors they are. So Kyle, what we're doing today is we are implementing we're writing some example applications in jank. And we're starting off with just a command line application that is going to do some JSON queries. So it's going to read a JSON file. It's going to receive a query, kind of like JQ, like imagine like minimal JQ. And then it's just going to output the result of that query. And so we want to like show all of this working with including a C++ header file and compiling down to a static runtime, like standalone executable and whatnot. And so the goal here is, as you probably saw, based on the maybe this is a good time to bring it up. Based on the survey that I sent out recently, recently being yesterday, is that like what I really want right now, today, what I really want is to get people to use jank. So obviously jank is not in a state where just everybody can use it. You know, like a new bank is not going to pick up jank today because they're a bank and they need something that is not alpha software, right? But there are a lot of people whose risk profile does fit with where jank is, and they're just lacking documentation, or they don't actually know that jank is ready for them to pick it up, or some other reason. And so what I did, and this is I don't actually know how to get to this from this browser, but we'll just jump to the Clojure subreddit. So what I did was holy fuck, where's this thing? Oh, here. I put up a survey, and for everyone who's watching the stream right now, if you have not filled out this survey, then please do, because I'm asking you to do it. It's fucking helpful for me to have you guys do this. And the survey, it asks you like, what do you want to use jank for? And so I want to know this because if everyone is interested in building standalone static runtime executables in jank, I'm going to like put more time into that. If it turns out that everybody actually just wants to embed jank inside of game engines like Godot and Unreal, I'm going to make that easier. Like I want to choose what I prioritize based on, you know, how you guys want to use this. And then, yeah, specifically like follow-up question on that. But then also like what, you know, why aren't you using jank yet? You know, what do you need in order to actually pick it up? Because it could be that what you think you need is already done. We have a ton of stuff that's done at this point, some of which I haven't even shown to you guys, like some of the stuff that Kyle was just working on recently. And then some more questions about the mailing list and whatnot. But my goal here with this survey and with what I'm showing you guys on stream and with coming up with these examples is to make it really clear what jank can do right now. And then to get in as many people as possible to just start using jank as it is. At that point, my priority, how I want this to go, is anything that you guys need, any frictions that you guys have or blockers that you guys have, those are the things that I'm going to work on, right? So I want to provide this sort of white glove support for all of you early adopters. If you like, okay, I want to build a functional game engine in jank, you know, like this is the time where Clojure is going to enter game development for real. You know, let's get our own jank bevy thing going on. Then like, yeah, fuck yeah, do it. Tell me what you need. You know, if you hit any issues with interop, if you hit any issues with performance, if you hit any issues with anything, tell me, and then I will prioritize it, because getting those sorts of things going, like that's what we need. That's what we need. Okay. If anyone has any questions about any of that, then let me know, because I'm fucking serious. Let's do this. It's time. It's time. Working on adding FreeBSD support. That's one of my blockers. Fuck yeah. Rebel Elder, if there's something you need for that, then let me know. Are transducers already working? What about Core Async channels with transducers? Transducers are working. Yeah, transducers are just functions, right? Those are working. We don't have Core Async ported to jank right now. So that has not been done yet. I tried your static runtime branch and it's very exciting. Finally, closure with without 100 megabyte memory usage. Kyle, that merged into main today. I merged it into main right before the stream. Had to get CI happy with all of that. But yeah, I mean, all like that AOT stuff is working on Mac OS and Linux and Windows. At least the MSys2 Windows build that we have. But yeah, it's super fucking exciting. I'm glad you tried it out. I'm glad you liked it. Yeah, and then DJ Blue's been doing actually quite a bit of work to get Jank working with Portal, or Portal working with Jank. I don't know how you want to think about it, but that's also exciting. So the other thing is, in terms of adoption, we need to get like 200 plus GitHub repos. Is it GitHub repos or is it files? It's GitHub repos, I think. We need 200 plus GitHub repos that are using Jank in order to be able to get Jank highlighted as closure code in GitHub. And that's just going to come from lots of folks doing doing Jank projects. So do more of those and put them on GitHub, because it actually helps. Even if you don't like the code, even if it's shitty code, it doesn't compile, put it on GitHub, because each of those counts toward us getting closure syntax highlighting for our Jank code. R2 ADHD2. Nice name. Bro making compilers casually. Well, you know, the thing is, compilers are just pure functions where you take in source code and you output some transformed representation of that source code. It doesn't have to be that complicated. A lot of people doing compilers have PhDs. I don't. Yeah, Pizrak. There's a good meme on that. C++, C# being like 4 pluses sort of stacked on top of each other. That's a fun one. Real programmers usually program on their own OS, but who might a discouraged beginner? Yeah, man. You gotta let the noobs do their noobing. All right. Bear with me. Okay, so we had this ambiguous thing. All right. Fuck, I already closed it. I got distracted. So we were looking at the if stream constructors. And so there are a bunch of these if stream constructors, and they take a bunch of shit. And so we have this one here, for example, that takes a C string. We have this one here that takes a standard string. Those alone would already cause an ambiguity. And so when we just pass in a jank object, the compiler is not able to figure out which one we want. If we specifically cast this to a standard string, then when we run this again, we should be able to So I didn't pass in an argument, and we didn't do any command line argument validation yet, and so we just get back nil. There we go. Are we working on a JSON library for Jank? No. So we're working on standalone example programs for Jank, and these are going to go into the Jank repo, and they're just going to be examples of how to use Jank with a whole project that are ideally easy enough to understand by just opening up the source and seeing what's going on. They're also going to have, I'm going to put README explanations for all of that. That way anyone can just sort of jump in and get an overview of what's going on there. But we're going to have some more complex ones as well. So we're starting with just a command line application that reads some JSON stuff, and we're using a C++ library for that. But we're also going to do some like graphic shit, I think. So we'll see where we get today, but maybe we end up doing some like SDL or like immediate mode GUI stuff today as well. Maybe Raylip. Okay, so what we want to do is we've constructed our if stream, given our file. Now, when we take a look at the JSON libs, all we need to do is call this JSON parse, and we give it our if stream. Now, jank is handling all of the C++ details for us. So if stream here is a stack allocated standard if stream object. When we refer to if stream here, it'll be a reference to that. And we'll call this JSON parse function. Let's do that. So we'll call man. Did I get that right? Oh, it's up here. I did. JSON parse. And I also forgot this, and then I put it here instead. And we're going to give it the if stream. Where's the survey? The survey is on the Clojure subreddit. It's also in the jank Slack channel. Let me get a link to that for you. Actually, I'll just open it up here. One moment. There's the survey. Fill it out. Help a brother out. Cool. So when we're going to do this, we're going to call this parse function, and let's see how that goes. Nice. So when we call this parse function, we're already doing function overloading, right? We're giving it our reference to our if string, and we're getting back this stack allocated JSON object. And then let's see what we can do with this JSON object. So here's if you want to assign some shit into it. I don't really want to. We can pretty print it by using dump. Indentation is supported if you specify a number. How do I look up values without inserting? I just want to do like is there like a dot get? At. I don't know if at works for maps as well. Okay, so basically we have our JSON object now. And what we need to do is we need to handle our query. And so our query syntax is going to be similar to JQ. So let's just do something like foo.bar, kind of like this. So dot will just mean like top level, and then foo will just mean grab the foo key, go inside of that, and then bar will mean grab the bar key, go inside of that. So JSON query foo.json. So let's do foo, and let's do this, and then let's do bar, and let's do this. So let's try this. So now our query is just going to be a string here. And we're going to read that in. That's just going to be a string. We're going to want to we're going to want to loop through this string. Maybe we should split it first. So we have our, I'm going to separate these. We'll do something like this. There's our JSON stuff, and then here's our query stuff. Do we have closure string stuff? I don't know. Query parts. Do we have closure string split? I don't know if we actually have this. Is JSON a jank map? No. So JSON, the variable here, Heldiana, is the output of calling JSON parse from this C++ library. So it is this guy right here. So we're calling JSON parse. We're giving it a standard if stream. So these are C++ values. So here's a C++ standard if stream. We're casting this jank object to a standard string in order to get the constructor here. Then we're calling JSON parse with that. And so this JSON object is actually it's of this JSON type here. Or just calling it JSON instead of data, because data is quite opaque a name. So yeah, we were looking at split. We can't use this yet. Jank doesn't have closure string split. Does Jank have regex yet? No, we don't have regex yet. Okay. So, no closure string split, no regex. We have regex? I thought you implemented regex. Why is it not, why is it not just called regex? Like I have like persistent hash map, you know, here. Pattern? RE pattern is what it's called. Oh, you did the Java names? Yeah, you should be sorry. I'm kidding. Yeah. No, I would have just called this, regex, but I think that the reason is, I think that you're right that this should be RE pattern, because there's RE matcher and then there's RE pattern. Yeah, maybe we can rename those in the future. Okay, so we do have that, but do we have closure string split? Oh, we do have that. Oh man, we're so good. We're so ready. Okay, so let's do closure string split. This takes a string and it takes a regular expression. So our string is our query and our regular expression is our dot. And that needs to be a regular expression like so. Let's just take a look at query parts. Query parts. And the other thing is that we're not using the REPL yet. Maybe we do that. Unable to resolve closure string split. Okay, found here. Good. So that's a helpful error. We just need to require closure string. Jank is getting there. Jank is, yeah, it is getting there. Nice. What? Oh, dot. Okay, so we have and also it would be helpful if we did, instead of this, if we did PRN, then we'll get a 2-code string. Yeah, maybe we should try doing some repling. Yeah, this is a lot more helpful. So here's what we're going to do now. Like, man, it's almost like, guys, it's almost like we're writing fucking closure. You know what I'm saying? So I want to remove empty. Honestly, guys, no, like Kyle, you're so right, man. You guys have written jank more than I have. That is just the truth. It's been a long time since I've written closure because I've just been working on the jank compiler. Yeah. And like mainly reviewing Kyle's recent changes that have all been in closure. For like there's the nREPL server, and then there was the jank perf stuff, and then the new build system stuff that's all either in jank or in closure. I'm just like, man, I don't even know this language anymore. Okay, so foobar, that's what we get. Now we have our query parts, and we have our JSON, and now all we need to do is basically a reduction. Assuming that we can just do a .at in order. The thing is that .at is like conventionally in C++, .at throws if the thing is not present. And I would like it to just give me back like a null. But let's see. Why not? So let's just do. I don't want this. So let's just do a reduce. So we have our accumulator, and then we have our value. We're reducing over the query parts. What is our initial value? Our initial value is initial value is the JSON. But if we're crossing function boundaries like this, then we probably ought to box this guy. Hey, Fromophobic. How's it going, man? Hope you're doing great. Yeah. But then we'll have to box and unbox, blah, 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 blah. So let's just loop. I think we can do this. I don't actually know. I don't actually know if we can do this. Query parts. And then what we'll say is if query parts is empty, if empty, then JSON. Otherwise, recur, and we're gonna do a .at JSON first query parts, and we'll cast that to a string, and then we'll also do a next on query parts. Okay, so this is a bug, and this is a known bug. The bug is that in jank, because all this stuff with native interop is statically typed, whenever you have an expression, like an if like this, that evaluates to some value, and you're using a native type as the result of one of the branches, then the result of both branches need to be compatible in terms of the type. And the jank compiler will help you out with this in some cases. So if you like, here's what I mean for an example. So if we just remove those, if I did something like, okay, so here's foo, and if something, then go ahead and make me a standard string. Otherwise, go ahead and give me a go ahead and give me one of these, an if stream, right? This is not good, because then the question is, well, what is the type of foo? And you might say, well, in Clojure or something, you could do this, because the JVM has a base object, big O object type for every boxed value. Oh, isn't that so fucking convenient? Well, C++ does not. And neither does C, and neither does Rust. The native world does not, in general. And instead, standard string, standard if stream are completely unrelated types. They're completely unrelated types. And so we can't just have foo be one or the other depending on this runtime check. Now, obviously, true is not actually a runtime check. So, you know, if we did something like count of args is equal to 5, you know, something like that. Then what the fuck is, like, how do I generate the type of foo for this? How do I analyze that? And then let's say I then later do a CPP. I do a CPP. I don't know, fucking like standard print, right? And I give it a foo. What's the type of foo here? Is it a standard string or is it a standard if stream? Or is it like is it a sum type, right? Is it a sum type that either holds a standard string or a standard if stream? Have we just invented sum types using this? No, we've not. Instead, what will happen is jank will give us this error that it just gave us here, but it'll say, okay, so on the one hand, you have given me a basic string char, which is a standard string for this branch. And then there's another one, your other branch gives me a basic if stream char, which is an if stream, because C++ has all these fucking templates and aliases for templates. And so this ends up being an analysis error, and it has to be. Now, the interesting thing here, and this is going to blow your mind. It's going to blow your mind. The reason is that jank is statically typed. Think about it. So C++ is statically typed. Is anybody going to challenge that? C++ is statically typed. Nobody's going to challenge that, right? Well, jank has the same type system as C++. Jank compiles to C++. So therefore, jank must be statically typed. And so this makes you wonder, what the fuck is static typing, right? In fact, jank is more statically typed than Clojure JVM is. And the main reason there is that we don't have this base object. that Clojure can fall back on and just say, anything will do. Give me anything. We can't do that without completely throwing away all type information, which we just don't do. Like if you do it like a pointer to void, exactly, Kyle. Then you could do that, but then you throw away all information. You have no like dynamic, like runtime type information way of getting back to the valid type. On the other end, whenever you use a pointer to void, somebody has to have the guts to cast that pointer to void back to the correct type. No standard any? Well, I mean, jank is C++, and C++ has standard any, so you could use that. But it's the same problem with standard any, Lemna, where somebody at the other end has to have the wherewithal to pull out the correct type. The only thing that standard any can tell you is whether or not you pulled out the correct type. If you try to pull out the wrong type, standard any will say like, well, that's not the right type. It's not going to tell you which type it is. It's going to say, that's not the right type. But anyway, C++ has standard any, yes, but C++ is statically typed. Everybody agrees C++ is a statically typed programming language. But even if you rule out things like standard any, when you look at object-oriented code, where you just have object hierarchies and you're passing around pointers to widgets, you know, like an old style C++, that's all dynamically typed in the sense that Clojure is dynamically typed, in the sense that jank is dynamically typed. Because you're using a static type system, you're like, yeah, I have a pointer to a widget. I have no fucking clue what type of widget it is. And widget is an abstract base class, so it doesn't have any functionality really on its own. It just allows me to get where I'm going. But it is statically typed. If statically typed list seems mind-blowing, there's a precedent for another list. Yeah, that's not my point, though. Because my point is that like something like carp is like fully statically typed, where the type of everything is known at compile time. Like the full type of everything is known at compile time. The distinction that I'm trying to make here is that you can have a complete C++ program where the full type of anything is not known at compile time, you know? Or like the full type of most things anyway is not known at compile time if you're just using a lot of object-oriented polymorphism. If you just have a lot of pointers to base classes or references to base classes, then, and that's basically your entire program, then at that point, you're basically a dynamically typed program. Because that's all Clojure is. And that's all jank is. Like, it's compiled to C++, which has a static type system, but it uses a lot of polymorphism. So I spell this out because I think it's an interesting thing, and I think that in some ways I question the utility of the terminology that we use by just saying, like, oh, Clojure is a statically typed language. People should just be using more types and blah, 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 blah. Like, I mean, Clojure fits very well into a statically typed, Clojure fits very well into a static type system. I have successfully modeled Clojure into C++'s type system. It works fine. It works well. We just have to rely on polymorphism. But a lot of C++ programs already do that anyway. That's all my point is. I think that's an interesting thing to think about. but maybe that's just me. Okay, so how are we going to do this loop? Oh, right. So the bug here, I was explaining this bug. Ifs need to have different, ifs needs to have the same or compatible types. If we can implicitly convert from one type to the other, then that'll be fine. If you give me like a float, actually, do we do that? I don't know if we do it. I don't know if we do, but we do trait conversions. But the problem is here that recur should just like skip the type checking here for if, because recur, like this expression doesn't really have a type, because it's never going to go anywhere. You're never going to get anything from recur here. But the jank compiler assumes that every expression has a type. And if it doesn't have like an explicit type that we're going to specify, then its type is just going to be like a base jank object. And that ends up being a problem here because the compiler says, okay, well, this branch is going to return this JSON object, which is a native value. And this branch is going to return a type erased jank object because that's just what it is going to default to if the expression doesn't have its own more interesting type to specify, and those two things are not compatible. So we need some sort of special handling for recur when it comes to the type checking of if branches, and I just haven't tackled that yet. But I'll note it down. Recur type handling in if branches with the native values. So yeah, I didn't want to write this with reduce because we'd have to do the boxing unboxing, but the loop would work fine if we did mutation. Yeah, it's just that. So we loop through our query parts. If our empty query parts, then let's just say nil. Otherwise, next, and then in here we'll do a do, and we'll grab this, and then we'll just do an assignment. In addition to carp, there's a few others. Look for ideas like type bracket. Yeah, for sure. You're missing my point, though. You guys are missing my point. Why did this fail silently? Some sort of crash happening here. Okay, now here's a good question. How do we debug when we're launching with line run? Maybe we should have like a command in the line plugin to launch a debugger. Because otherwise you need to figure out the command that's being used. We do have this -v though, which I just remembered we have. What's going on here? Yeah, okay, so we're doing at, presumably. Yes, so here's at with key bar, and we are throwing. So we're doing foo.bar. Foo is going to give us a 2, and then we're not going to have a thing. Yeah, blah. Okay. So what do we do? Is there a graceful... I don't think there is, because I've scrolled through so much of this already. We're already getting into the complex shit. So how does this represent null? Okay, just empty JSON object. So what we could do is we end up doing a try here. And in here we'll do a let, and we'll do a this, and then we'll do a this, and we'll have a catch, and we're going to catch what type? Nice does not tell me what type. Nice. Interestingly, though, we get an exception, or we get a segfault when we're trying to print. Okay, so that should not crash. This is something to do with the static runtime. So printing exceptions should not. So it didn't always. Sometimes crashes. Wait, no, we're not. We're doing a line run. So that's not static runtime. Dude, yeah, we'll try dot contains. We should do a let for this, because we're going to need to refer to it a couple of times. If contains JSON S, then grab this, grab that. Wait. You. Okay. And then otherwise, this is going to be equal to CPP JSON. grab our string. If the JSON contains a string, then do at and assign, otherwise equals empty object. I see. Is that actually a struct? Ooh, code gen bug. So S31. So the equals here returns a reference to the JSON object. And with the way that this works, because Clojure is an expression-based language, the if here is then going to produce a value of that type. I'm not sure what a good default is for this, what a good default behavior is for this. Because so the problem is, like, each of these returns a reference to a JSON object. But because I used it as a statement, I really don't care about the value. But jank is trying to helpfully be like, okay, let me get you some like if result thing, and then in each branch of the if, it's going to assign to this if result, but it's already a reference, and then it's trying to default construct this reference. And it's a reference because each of these branches returns a reference to JSON. And so sure, we could strip off the reference, but then we'll just end up doing a copy of this thing, assuming this thing's copyable. I'm just not sure what we actually want. One thing we could say is, okay, well, if it's in statement position, then just don't bother, which is a code gen optimization we just haven't done yet. But if we want to be more explicit, then we just end up saying like, ignore this result. But yeah, like, I don't know. This sucks. Like, having to do this sucks. But I'm not sure what should be done instead. Catching up sourcer, didn't mean to distract, just give an example. So let's pair instead of this. Even Clojure itself is some type hints, core typed. I think your point is that jank that calls C++ needs to know what type is being dispatched at eval time, not eval time, at analysis time, i.e. at compile time. So it's either fully static and is a direct function call, or at least a virtual lookup table from a particular base type. To me, it's so much simpler. To me, jank is just C++. That's it. Like, jank uses C++'s type system. Jank compiles the C++ code. So C++ has a static type system. You can do virtual dispatch with it. You can do runtime polymorphism with it. But it's still a static type system. If you're calling a C++ function, you have to have all the types necessary at compile time, because you have to do overload resolution. You have to know the definitions of these types because you have to know the size of the types. You have to know if the types are copy constructible or move constructible. You have to know if they're trivial types or not, so that you can set up destructor calls at the appropriate scope. Like it's just static typing through and through. It's static typing with runtime polymorphism. That's it. Just like you would write a C++ application and that is object oriented, and you have widgets and then a whole bunch of base widget types, or like derived widget types, and you're just passing around pointers to widgets. Is there a good place in the jank book that's a good reference, or is the best option a good C++ book? Yeah, we don't have anything in the jank book for this stuff. Like, I think to really understand jank, you just have to know C++. If you know C++, then jank makes a lot of sense, I think. Unfortunately, in the Clojure community, there are not many people who actually know C++. At least who know C++ well, anyway. And of the people working on jank who know C++ well, it's probably me and Kyle. But yeah, I mean, maybe Kyle can chime in if he agrees whether or not with what I'm saying, and how this makes sense or does not make sense. Okay. I think dump just gives us strings, so let's just try this. It does. Perfect. Okay, so let's try with foo. I want to bridge the gap better. I want to gather some C++ primary material. Yeah, that's one thing that I need to be able to answer better, because it's something my mentees ask me as well, which is like, how do I get started? How do I get better at C++? And I don't have a good answer to that right now, because I haven't read a C++ book. I haven't read a C++ book in over a decade. Yeah. Okay, so this is, we have our working application, but I don't like how it looks right now. I don't like how it looks because of this. So I'm just gonna, like, I don't have a solution to this one, but I just want to document it here. So on if with 2 CPP equal, we'll have codegen issue constructing a tref even in statement position. Yeah, so I don't know what we need to do there. And where we're at now is just like, how do we clean this up? How do we clean this up? 27 lines. I don't like these do's. I don't like these do's. I also don't like the loop. Let's try to see what it looks like with a reduce. Hey, Johnny. How's it going, man? How's it going? Does it matter to reduce? It's not much of a reduction if we don't care about the accumulator. In that case, we might as well just do a do seek. So here, if we just do one of these, the issue is that almost everything still works, but a lot of isn't a good idea anymore. Yeah, that is an issue. You're right. So this is cleaner. Trims off a few lines and should work just as well. You can use swap. Void is implicitly convertible to nil. So we should just be able to do this, is what you're saying. Oh, code gen issue. So, okay. And this is, yeah, this one's like actually just a code gen issue. So if with a void branch, needs to code gen to nil. No, but this, like, you should be able to do this one, com. And this ends up being a lot cleaner. But yeah, I don't know. I feel like it's going to be a relatively common issue to do the, like, to do the assignment in, or like to just have an if that calls some, I wonder if we just want like a macro What do you think of this, Kyle? If we had like basically a macro where instead of like a do nil here, we just do like a, I guess bang's already an operator, but if we did, I don't know, double bang or something, but if we had a macro here that basically says like, this is an effect, just do it and return nil. Then in these cases, you don't need to worry about the types of things lining up, because you could just do your effect. Why does CPP equals return a value? Well, because the equals operator in C++ does. So equals conventionally returns a reference to the thing that was assigned, and that allows for daisy chaining. Hey, Johnny. 10 stream streak. I appreciate you, man. So yeah, like porting some code from C++ to jank, I imagine it's gonna be very handy to have the daisy chaining of assignments. That would especially pair well with the thread first operators, probably, or macros. Yeah, so best idea I have right now is to have some sort of macro that just does an effect and then chucks, well, it doesn't need to chuck the value, it just needs to evaluate to nil. But yeah, for now, let's just do a swap here. Delete this, we'll do a swap. And then let's fix this. Let's see, is there anything else we want to change here? So we bring in closure string. We bring in fstream, JSON. We don't do refer global for any of these. We could. We grab our file, we construct our if stream, we parse our JSON, we grab our query, we split it, remove the empty bits, and then we loop through our query parts, cast each part to a string, and then dig into our JSON. By the end, we print our JSON. 20 lines. I'm cool with this. But we need to fix this codegen issue. So let's do that. So that's a branch. So this is the codegen, but we should have the type. Okay, yeah, we are doing is void checks here. So shadow sum, qualified type name. So I could do a void check here, but it just doesn't make sense for there to be a shadow variable with the void type in the first place. I just don't like that. So we say if the expression position is not tail, then we have this shadow. And the shadow type is a mutable type. Okay. So this will adjust the type system so that we'll normalize void in the cases where we want a mutable type to an untyped object ref. So that should fix this issue. And then do we need, we can't do that yet. So we want to try, once this is working, we want to try to AOT compile this to the static runtime, make sure that the executable works just fine with the library that, you know, the header that we're bringing in and everything, and it still behaves as we want. And then we'll be done with this example. Call it good. I'll worry about the documentation and everything like that later. All right, while this compiles, I'm gonna use the restroom. All right. Let's go back to here. See how this goes. I hope that works. It does. Cool. Yeah. So let's line compile. Nice. Yes. So this is because we didn't do this and that. And, okay. This is an actual bug. Something to do with the way regular expressions are compiled. So we can see here, we have nice source information. This says we're at line 12 right here. So we're about to call closure string split. And we're in JSON query main. And then we end up calling closure string native split. And then we throw here. And we're throwing, the error says that we expected a regular expression pattern, but we were given a small real. A small real. So the reason is that I believe we have a global that's not being initialized. So here's all the C++ that goes into compiling this. Let's take a look starting from here. I see. I think it's going to be this const 205. So this is our lifted regular expression. I'll yoink all of this into Vim just so I can prove my theory, but I'm pretty sure. So let's take a look at how this is used. Yeah, so it's used right here before split. And we call split. Split is v7. It's the second argument. Yeah, so right about that. And we initialize it by So the problem here this should fix this problem, but it doesn't fix the overall problem. It just addresses this one instance of it. The overall problem is that, well, take a look at this again. So const 205 is it's a lifted regular expression literal, but we mark the type of it here as an object ref because we are only handling explicitly some, like when we do code gen, we're only handling some types. So this is our little code gen type given some object. And then we use the Clang API to resolve some types. And then if none of these match, then we just fall back to the untyped object ref. And so that's this object ref here. And so this guy, because we didn't have explicit support for RE pattern in here, it got code generated as a object ref. And then when we later initialized it with a placement new, we initialized it in place to hold an object ref, but the value that we actually initialized it as is an RE pattern. And so basically, like we initialized an RE pattern in the space for an object ref, but they're not the same thing. They're not the same thing. And so we need to be able to detect this case. We need to be able to detect this case. I think I know how to do that, but I'll leave a note to tackle this. So detect lifted literal as object ref. Sure, erasure for placement new. Okay. So let's try this again. Should work now. Maybe. And then we're invoking this. Okay. So we're printing the whole thing. Why are we not doing the .foo? Clearly we're getting the first argument. Clearly we're getting the first argument, but the second argument it is what it should be. And query parts. And S might as well. Why is, okay, so clearly our regular expression still has an issue. That makes sense because I didn't even think that we had regular expressions. So there's something that we are missing. Let's print the code gen for this again. So we have an RE pattern ref now for this, and we have 218. So we have 218 here, V9 is used here. And then we're going to initialize 218. here. And we create an RE pattern. I see no issue with that. I see no issue with that. What do you mean, Johnny? RE pattern? This is what we're looking at right here. Shouldn't the backslash be escaped? Yeah, that's a really good catch, Johnny. That's a really good catch. Shout out Johnny. A lot of people don't like backseat coding when the chat helps. I love it. So I don't know how long I would have been looking at that one, and I was not going anywhere near there yet. I didn't have any theory yet. That's a really good catch, though. I think you're absolutely right. So we need to do RE pattern. This, we remove the thing. This needs to be, yeah, we don't want to do a code string. We want to do a toString. Pattern. I just want to grab the pattern from it, I think. So here we need to, we just need to do this, and then we need to do a util escape. Yeah, C++ doesn't have regex literals. It does have these literals, though. It does have raw strings, which is this R string thing here, which is why like we don't have to escape these quotes. You're all good, Sorcerer. It is not on you guys. You have no responsibility as viewers. But occasionally you do a great job of spotting something, like Johnny did here. Yeah, you get to choose how far back you want. If you want box seats or you want to be in the balcony, you know, up to you. There's not a bad seat in the house. Nice. So that fixed us some buggers. See, all we did was try to make some example shit. So the thing is, like, this sort of thing, we need a test for that void thing. Test for if with void return in each branch. Because we did fix that, but we need a test for it. And then this thing that we just fixed, where were we? Right. So this thing with the patterns is specifically an issue with patterns in AOT compiled binaries. I think what we should end up doing. I don't know how we want to encode that in a test. Yeah, I don't doubt that, Sorcerer, and I look forward to it. Because a lot of this stuff is handled by the closure test suite that we're just not running fully yet. Okay, so S is foo, and then null. Okay, and then why do we have null by the end of this? Because we should have 2 if we're just getting foo. Oh, it's because I commented that out. Okay, so now we're back to everything. We did it. I think this example is going to work. Nice. Nice. And then we'll do a nested one just to be certain. Comma. Nested. And inside of here, meow. Meow. So we'll do nested meow. Yeah. And it takes 33 milliseconds, which is well under 50 milliseconds. It's instantaneous, right? It takes longer to show my prompt than it does to do that. I do wonder. I just do. I don't even get into a. Yeah, because I have a. I don't know how to get into a bare bash prompt without actually like changing my bash RC. But I will be interested to see like, you know, like, because I know there's like some visual lag from rendering all of this with Starship, which is what this comes from. But I wanted to know how fast it would feel, you know, with like a really stripped down prompt. Anyway, it doesn't matter. We get to know exactly how fast it is, and it's plenty fucking fast for me. I think when these binaries are starting up under 50 milliseconds, I don't care if it's 20 versus 30 milliseconds. That's all instantaneous. And Graal native image will do this thing a little faster. So maybe this would be like 10 milliseconds instead of 30. I don't care. What I care more about in that case is that the binary is smaller, and ours most definitely is. 9.8 is well under what a Graal native image would be as well. So we don't. Babash can go down to like 1 millisecond or something. Yeah. I mean, at that point, like, it doesn't matter, you know? I'm cool if we want to like get this down further. But I'm not stressing about that. And I know how we can get, I know the two things that we're spending our time on. Like I know where all of this time is going. I just don't think it's worth the effort to go lower compared to the other stuff we got going on. Maybe if we get to a point where that's the highest priority thing, then sure. So I'm going to do a resources directory, and I'm going to move foo.json into there. That way we can just use that. Like so. Nice. Okay. So let's delete this and that and that. So any feedback on this? What do we think of this? What do we think, chat? Are we satisfied with this overall example? What about code review as well? What do we think about the code? We have 20 lines for this example. I think that when I commit this in, I'll end up commenting. I'll end up adding comments, probably another 10 lines of comments for just what various things do, how they work, what to know about them. But I'm pretty good with this, I think. Do we need the cast here? No, we don't. And just to be sure, so yeah, we only need a cast if we have an ambiguous overload. If the overload is clear, that only one of them, because what we're doing is we're doing a implicit trait conversion. So part here is a object ref. It's a type erased jank object, and then contains here takes a standard string, s. Part. Yeah, so we'll have to see if this flies. And so the jank compiler will, when it's doing overload resolution, will say, oh, okay, so contains takes a standard string. We have a type erased jank object that doesn't match overload resolution. But then it does a second stage where it says, okay, do any of these overloads match overload resolution if we use implicit trait conversions, where we go, where we use the convert trait in the, basically it's kind of like Rust's into. that is written in C++ templates. And you can specify those for whatever type you want, and jank already specifies them for things like standard string and integer types and floating point types and whatnot. And so the jank compiler will automatically pick up like, okay, this thing takes a standard string. I have a type erased jank object. I can actually get a standard string from a type erased jank object via this trait conversion. And so it generates that in for us. Okay, so we can do that for the contains, but not for the at. And in that case, it doesn't actually save us anything from doing it. So we'll just use it in both. By the way, how does jank store the actual native object type as a string, as a table entry, compile time string to integer? How does jank store the... You mean like, how does the compiler represent native object types? Is that what you mean, Johnny? So the first thing to keep in mind is that, to answer your question, Johnny, I just want to clarify, we're not using CPP box anywhere in this. So like this if stream, like that's a straight up C++ value on the stack. This JSON value is a straight up C++ value on the stack. This standard string is a straight up standard string on the stack. And these mutations that happen on the JSON value are also just like we're just working with C++ values here. So CPP box is specifically for when you want to take a native value, a pointer to a native value, and turn it into a jank object. And what we end up doing is it's basically like a standard any. But not quite. Similar sort of goal. And the type for that is stored as a string. So we just have an immutable string canonical type. Yeah. And so we get this type from Clang. Because when you box, so in your code, you did box standard string object. You don't actually do that. In your code, what you do is CPP box object. Because we already know like the type of everything. Could use a string to integer cache. Why? I mean, yeah, probably, but why? What's the goal for that cache? Is it just to avoid a string comparison and instead, like for performance, to do an integer comparison instead? Hey, Doc Walk, Michael Fassbender. What are you talking about? Are you saying I look like Michael Fassbender? In which case, welcome. You charming, charming chat member. Because Michael Fassbender is a handsome man. Store one extra integer per native object instead of a string of an arbitrary length. Per native object. But we don't want to do this per native object. Like opaque boxes, CPP box is like a very specific edge case, like these, we don't want to store additional data alongside this if stream or this native JSON value or this native standard string. That's just going to blow up the memory usage of everything. And then the other thing is that the string that's inside of the opaque box is a complete implementation detail. That's never used by the user at all. When you want to box something, so let's say I take the address to this JSON value, right? So we'll have a pointer to JSON by getting the address of this JSON value. And then I box that by doing cd box. And then if I want to unbox that, then I just specify the type. So here's my pointer to JSON again. Now I unbox, and now I need to specify the type. And the type of that is going to be this guy. And I don't specify the type as a string here. I specify the type using the type DSL. JSON box. Like so. So here, when you box, the compiler automatically puts in the type information into the box for you, because it has to know the type of this value already. So you don't need to worry about that type string. When you unbox, you specify the type that you're expecting to get out of that box, and you specify that using the type DSL. You don't specify that as a string at all. The compiler handles converting them to the canonical type and then comparing them. If we compare the string, or if we make a table and compare integers, it's the same thing. I meant that there would be a map of string to integer used for boxing and integer to string for unboxing. It would make all runtime objects cheaper for some static overhead of maintaining the cache. Yeah, I don't see the benefit. I don't see the benefit, but it doesn't mean you're wrong. It just means I don't see what you're talking about. But if you want to follow up with like a gist or something like that, where you're giving more info, you're absolutely welcome to, because I do want to understand what you mean, but I just don't see how that would be an improvement over how it currently works. I also if the problem that you're trying to solve is an optimization of the string comparison for opaque boxes, like very specifically CPP box, CPP unbox, then it's a very that's a very niche thing to optimize when we have no indication. We have no profiling results that would suggest that needs to be optimized. So one of the mentalities I have when developing is just and you guys have all seen this in my blog posts and on stream, is that I'll make a benchmark. And I will profile the benchmark. I'll figure out the slow points. I'll optimize those. And if something is not showing up in the profiler, then it doesn't matter, right? There's no point spending time on it. I don't think that the opaque boxes are ever going to show up in terms of performance, but if they do, then yeah, we're going to find a better way to do it. If there's some other benefit you're going for, I don't understand. Okay, so this is our example. That's our JSON query command line example done, and it works with our static fucking runtime. Bam. Bam. Next, let's do a graphical application, and we're gonna do it right now. We're gonna do it right now. So let's do, again, I want to get back to here because I want to figure this out. I want to grab this. And we're going to do, so here, we need to decide what kind of graphical application are we going to do. I don't know what GTK Plus looks like. GTK Plus is for C++, right? GTK MM? What's that? Isn't MM like Objective-C? Doom, obviously? Or are we gonna like rewrite? Are we gonna like rewrite Doom in jank? I remember GTK being horrible, but that was plain C API. Sure. Like I'm just exploring right now. Like, what do we want to do for a good example of a native desktop UI in jank? Like to take advantage of C++ interop. I imagine that Qt may be difficult because of its meta object compiler. Oh, you don't think I want GDKMM, but it is the C++ bindings. Probably just want the C library. Gotcha. Oh yeah, this is just gonna be a bunch of fucking object-oriented stuff. Like, oh, let's wrap things in classes just because. Yeah, we don't want to do this. Okay, so we could do GTK. We could do some imgui thing. I know there is some other like immediate mode UI stuff. Like there's nuclear. That's nuclear. That's immediate mode, right? Nuclear. I don't remember exactly how that's spelled. The library. UI lib. Nuclear. Oh, with a K. Yeah. Okay. So that's also immediate mode. So probably no clear win for using that versus imgui. GUIs are why object-oriented languages got popular. They tend to be unwieldy in plain C. The overwhelming success of immediate mode GUI suggests otherwise, but I do know what you mean. And I do know that a lot of GUI frameworks are seriously object oriented. Seriously object oriented to a fault. Maybe we do. So Linux desktop GUI lib. Yeah, I was just thinking maybe we do imgui. Oh wow, Wix widgets. Framework. I don't want any of these. Man, what the fuck are all these? All right. Let's do some imgui. 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 I struggle so much with this name, Okernut. I just always read it as like corn nut or like coconut, corn nut. Like I think I end up putting like a C in the beginning of this with my brain. And then it's kind of like coconut, but with an R, coconut. And I end up just being really wrong. Bro's name's Omar. What's the... Oh, it's actually his last name is Cornut. So it's Omar Cornut. Okay. That'll be easier to remember now. So the thing about imgui is made for debug. More efficient? Question mark. Kinda. I think there's an element of truth to what you're saying, Davros. I think that historically, immediate mode GUI was really helpful for debugging, right? Very easy to just hack it in. It doesn't need to be fast. You just want to get some UI rendering because you want to be able to, you know, make a debug UI or render some stuff that's going to help you visualize the data that you're working with. But as GPUs got a lot better and we got a lot better at putting things onto GPUs, and also as more and more things just become like rasterized to the point where we are intentionally rendering every single frame, and then it's just like, okay, turns out this is not like, it's not actually a problem. Yeah. Yeah, I mean, back in the 80s and 90s, we're not even doing like a lot of rasterized graphics, right? Vectorized graphics were more popular in games, and we had 3D vector graphics. So we had, what was that flight? What was that 3D flight game with vector graphics? But anyway, so we had like interesting 3D worlds, and we were using vector graphics because it was a lot faster to just draw those lines. But with rasterized graphics, we had to actually take a huge step back for visual fidelity, as well as like what games were able to do, because we had to clear the screen every single frame. And that's just like, it was so wasteful. It was so much more work to do that when games started using rasterized graphics, it was like a big step back in terms of fidelity of the, you know, the visuals. as well as like the mechanics that could be involved, just because so much time was being spent just clearing the screen and then filling in all the pixels. But then, you know, we just optimized and optimized and optimized the hardware for that and the software for that, and now we have no problem clearing the screen every time. And in fact, we have no problem double or triple buffering. Yeah. So I think that's roughly the history. But where we end up with is like, it's some of the most efficient desktop UI software, if they want like rich experience, ends up being in media mode. Like, I know they have pictures here, like Tracy, for example, is like just amazingly rich in terms of the data and visualization of everything, right? And that's, everything is real time and moving and incredibly like information dense. And it's because I think it's using immediate mode UI that it's able to do this. I think if you were to try to implement something like this in the classic like retain mode UI, it wouldn't work well. I don't think it would work well. But I could be wrong. I could be wrong. I'm willing to be wrong. It's not a hill I'm going to die on. So let's see. We have a getting started guide. I know Kyle's actually already done some immediate mode GUI stuff with jank. So I believe what we need to do is we need to grab a backend. So let's just do GLFW with OpenGL. Welcome to the stream, AA Potham. Hope you're doing great. Or I pot him. So I think we need to get these headers. And then we'll probably do something similar to what we did. So let's GLFW. Okay. So we'll do our libdir just like we did before. And then I'll open up the project and I'll jump into here and I'll say includers lib. And then we will jump back into here and we need to grab the wait, there's a CPP file here? I thought that we only need the headers. So our example here with the make file, let's take a look. So our sources are just this, but okay, so we do have sources here and also here. Okay, so there is indeed, we do have to get other shit. I wonder what is the easiest way to do this. I also wonder if we should be using, like, is this a good use case for the new native build system stuff? If we actually have some C++ sources we need to compile as well. I want the artifacts. I appreciate the very fucking thorough release notes though. Jeez. Okay, so this is just source code. There is no like easy download for. I have a make file in my jank imgui repo. You can copy it. I think so. Also to find the system GLFW. Okay, so you think we should use the native build system? Okay, we don't have any docs for this yet. So this is going to be. This is going to be a little more interesting. So if we have an imgui sys library that then has a jank build script, then we'll have to install that locally. Okay, yeah, this ends up being quite a bit more involved, but maybe that's what we want. So let's take a look. I'm gonna jump to Kyle's GitHub because he's already got some of this stuff going. I didn't want that. Oh, look, jank imgui. So that's one thing we want. But also, I think we want this playground. Yeah, you know, you have this plus release here. I don't actually know if we're doing that in the docs currently. With profile book. Wait, are we not doing that? Huh. I'm questioning whether or not that that did what I wanted it to do. It did not do what I wanted it to do. Yeah, right here, we want a plus there. Because we want base plus that. You can use the jank GLFW3 from the playground as well. Yeah, I just didn't know if, like, I don't know how long these are going to be around or maintained, Kyle. And so I didn't want to, like, just use these directly, but I will copy them in. assuming that's okay with you. Yeah, just copy. Okay. So here's our jank build, BB. And then Johnny, you're asking, does jank possibly have a future with WebAssembly? Yeah, for sure. Absolutely. Totes does. Yeah, I don't have BV set up to be closure file type. Do we not have a namespace at the top of that? We do not. Technically, they're on closures. Exactly. Yeah, I didn't want to just be pulling from some random thing because I wanted these examples to be standalone. I want people to be able to like see something and study it. And I also want these examples to be like, this is how you should like package a library, you know? I'm going to have a guide. I'm going to have a couple of guides in the book. One of them is going to be specifically about like building a command line application. And then we're going to maybe we'll even just like do a guide through the example that we have and then just link to the example. We're going to have a guide for building like a imgui application as well. Like a GLFW. I'll probably not target it as imgui. I'll probably just target it as like a OpenGL GLFW application that also uses imgui. And that's just going to sort of walk through what is needed to set these things up yourself. Hopefully that gives people the tools that they need to then start wrapping the libraries they want to wrap. And then we can, and ideally follow the patterns that we're trying to specify. And then everybody can just start wrapping whatever the fuck they want. I'm going to spill water on myself. Okay. So I'm just going to keep these as they are. We require closure string. We require a Babashka process. We call package config. We trim. And we don't want this. We grab the include dir. We grab the lib dir. And then we... Okay, so that's our include dir, that's our link dir, and then here's our link library. Okay, nice, I like that. Let's remove source and target and test and license from here. We just have a project and a jank build. Yep, that's what you have as well. Now the project for this, yeah, you don't have anything going on in here. So I will just leave mine as is. So let's see if we can get this will be, oh, this is for GLFW, not for imgui. So I need to copy this to GLFW sys. And so we have GLFW sys that just has those files. You need verbatim paths from project, OJ? This is to make sure that it goes into the Uber jar. Yeah. Okay. Is there, we don't want this. I mean, we should have the middleware already, right? Because this is a jank project. But we don't actually want this. Like, we shouldn't have to do this. Oh, whoops. Sorry for the black screen there. The line jank plugin should already be specifying verbatim paths. Why not? This is a well-known path that that line jank should just look out for already. Am I wrong? Yeah, the middleware could auto include jank build.bb, sure. Okay. Let's do that. So here's our middleware. I think we'll just do an update. Whoops. And verbatim paths. Verbatim paths concat. Jank build.bb. Move 2 lines up. Why? Because we have verbatim to file specs. Okay. And then I need to go into line jank and line install that. Okay. Here we just have the middleware and GLFW sys. Okay. And then for imgui sys, we also have the middleware. And then jank build for this. This is basically where we need to do the work of your makefile. Oh, I see. This makefile was just copied from the examples. Or just use the makefile and run make. Yeah. Yeah, we need that. So copy raw file and okay, so here's our make file. Now the make file has sources. It's looking inside of this imgui directory, and this imgui directory here, if I'm not mistaken, is a submodule, and it is. So we should just do the same thing, I think. So let me grab imgui here and copy. And then here, I'm just going to do following the design of everything else. I'm just going to put this into a libdir. So let's see. Okay, so package config wasn't finding GLFW on XOS. If I enter a shell with GLFW, package config still doesn't find it, but GCC does anyway. Do I have package config in my shell? Yeah, but GCC found imgui anyway. Oh, the problem is if we're surfacing everything with package config, yeah, I guess we'll have to see how well this plays. We'll have to see how well this plays with the build script. This is gonna be fun. We're gonna find out some shit. So the include directory, we don't need a command for this. The include directory is just going to be lib imgui, and then all the headers are right there. And we need backends as well. So lib imgui and then lib imgui backends, I think. But these should be absolute paths. So we probably want something in Babashka to get the current directory. File system. There's probably a current directory here. CWD. Yeah. So we'll grab that here and process file system as FS. Why does GC associate with Terry Davis phone class for me? I don't know. You need to put the build outputs in the correct output dir, not the current dir. Yes, so I'm passed in some data, right? I'm passed in. How do I get passed in this stuff? I should have written documentation for this when I first learned about all of it. But I'm figuring it out now. So that's in your jank playground. I think I have I thought I had the playground open, but apparently I don't. So there's a dynamic var. The problem might be that make will try to place the build artifacts in the source tree. You didn't parse standard in. So you're doing a copy of the include-dir. Okay, so I see. So we don't even want to point the include directory to the source directory. We want to install everything, including header files, to the output directory. Right. Yep. That makes sense. This is incredibly, sorry for the black screen. This is incredibly enlightening. Okay. So let me edit this from imgui sys build. And then I will use this directory. So probably want to just glob all of these files here. And then all of the backends. So we probably want to do a glob. Hey, Rainoffs, how's it going? Yeah, I think maybe I'm worrying too much about keeping the output dir like as minimal as possible. So if we take the source dir and we copy lib imgui, and we put it into outdir imgui. We don't even need outdir im. Why don't we just copy it into the outdir? With replace existing. And then do we automatically do include dir for source dir and link dir for source dir? I don't imagine. I hope we don't, because I don't think we should automatically do anything like that. We don't. Thanks. Also, Kyle, it's so incredibly helpful to have you here while I'm doing this. I could have figured all this out myself, but it is, yeah, but this is so much easier. Thanks. And then our linkter. Well, I mean, we could also just do the source dir, assuming that we just build. If we just run make first, and then we do the copy tree, then everything will just be. Oh wait. So no, we're copying lib imgui, but when we make, everything goes here. So we need to copy. Let's just see what we could do about. Yeah, this is stripping out all the directories here. I think if we do a, so first off, let's do a make. And where do I get the directory that this runs in? I do a line compile to test the build script. Yeah, that's, that is going to be helpful, but we're not there just yet. Builder is the current working directory. Oh, so there's another one called builder. I want to give Bashka process. I want to give, I want to tell SH where to be. So shell takes the dir. I think sh is sh is a convenience function. But that means I don't get to set the details. So we'll not do that, and we'll do shell instead. I just want to know how error handling is done with shell. Okay, so it throws. Got it. So let's do shell, and then this was not a vector. It was just a bunch of strings, but the first argument can be a map as shown here. Dir builder. sh forwards args to shell. There's a dir option. Let's see. sh just forwards the args. So the args that are in the vector. We'll try that. Okay, so make in the builder. And then copy the lib imgui to the outer and replace. And then also we want to copy the source dir. So we are going to do so there's a lib imgui.so. And we want to copy that to the outer. And so this ends up linking to this, and then imgui is what our link library is. And then we don't use package config at all, which means we don't need this. Wow. Just killed my highlighting for that. We're not using that. Okay, so if we do a make clean and a line compile, so it doesn't pick up the build script. Do I have a new enough, yeah, do I have a new enough middleware in here? This is, I think needs to be 7. Yep, there we go. And so we can't locate Babashka file system. I just looked this up. It's called FS, right? It's called FS. Cannot run. Okay, so we can't actually pass this. Do we? There wasn't an example, so I'm just going to try passing this like that, and we'll see if that works. Wrong arg order. Oh, so this... there are only a few permutations here. Okay, and then this says that this is not a directory. Oh, this is copy tree, that's why. We don't want to copy tree, we just want to copy. Nice, okay, where are the docs? Docs. Copy. Okay, there's just a copy. So we'll do copy. No such file because the make didn't work. Also, you're running make and builder, which is empty by default. Yes, I want to run make and source dir. Yep. probably want to copy source.dir to build.dir, then copy the output artifacts to out.dir. Because source.dir is not writable. So I want to copy everything into build.dir, then do my make, then copy everything into the out.dir. I got you. I got you. So let's just say copy source.dir into out.dir. And then do... I don't know what this is going to print line out.dir. Oh, I guess I need to go to standard error. And we had an example of that in we had an example of that in jank JSON build. No, we didn't. We had an example of that somewhere. Wasn't here. It was part of the playground. This. So we just bind out to error. Okay, gotcha. I want to see... I don't know if this is cleaning up the output directory each time, but it'd be nice to be able to look inside. We're failing before I even get there. So we cannot copy source directory under itself. It's just under target. All right, hold on. I got to understand this. So let me let me look at my data here. Let's see what we're working with. So output.dir is target. Build.dir is some temp.dir. Output.dir is target. And source.dir is where we currently are. Okay. So I was trying to copy source.dir to out.dir, but out.dir is part of source.dir. I wonder if this is a common pattern, and if it's more annoying to have to worry about this. Because it seems to me like there's going to be a pretty common pattern of, okay, take the sources, put them into the build.dir, do an in-source build, and then pull out the pieces that you want into the out.dir. CMake would handle it for you. Yeah, I wonder, does does make actually just accept a flag to build in a different directory? Man, I didn't get anything useful with that search at all. Directory. So if I went into build and I did a make of that. Wait, see. So this is going to change directory, but it's still going to build in the, yeah, it's still going to build in the source directory, right? Yeah. So that doesn't actually help us. I don't think there's anything we can do about that with make. That is indeed annoying. I think we'll just copy the make file. Just need to copy the source-dir imgui, not source-dir. So if we have our build there, I would need to copy the make file and also lib imgui. I was just wondering if like it would be cleaner to copy just the make file and then like patch the paths. If you specifically set up the make file to be patched like that, in the same way that CMake, configures files. Yeah, it's just all, it's all messy. I feel like, and this is, I hope I'm not throwing shade. I'm not throwing shade because this is a brand new system that, that works now. I'm just like, I'm feeling the friction, and I think that it's a good thing. Like that's why we're dogfooding here. But this is the sort of thing that, I mean, it's the sort of thing where examples are going to help, but it's also the sort of thing where I want to chew on whether or not we can get some helpers for this sort of thing. So we want to copy that tree, and then we also want to copy the make file into here and replace existing on that. Yes. And then we'll do a make in the, builder. Then we'll do a make in the builder. And then we will copy, we copy from source dir, that's fine, to out dir, and then we'll copy the build dir to out dir. All right. Okay. So our output dir here was this, which is target. And so we ended up with our headers, sources, and also our compiled lib. So that works. Everything there looks good. And so we get rid of this, get rid of this. Okay, so now we have the imgui sys package and we have the GLFW sys package. And now we just have to try to use them. I think we want to install them first. So let's do line install. And imgui sys. I need to check the version of them. Yes, exactly what I was saying. We're on the same page, Kyle. So this needs to be bumped, and then might as well just try a line compile on here, see what happens. Yep, so I am not in my shell that has GLFW 3. Yeah. I can try that. Let me also just try adding package config, see if that does anything specific. Like it does seem like it's using package config. I don't know if it's sets anything else up. Isn't that so odd? That works. Yeah. Okay. So we end up getting include dir and lib dir and linking. That's perfect. Chef's kiss. Ooh, let me just make sure I do a line installed there. I don't remember if I did. Okay. Now, inside of the project for this guy, we're going to bump the version for that for plugins. And then for dependencies, we are going to do GLFW sys. That was a 0.1 snapshot. And then also we're going to get imgui sys like so. Now here, if we were to do a line run, what happens? Which OS is this? This is Linux. I'm running Nix OS. So nothing happened there. What if we do a line compile? I was expecting that we would trigger the build by having the dependencies. It should build the depths. So we have the middleware is 0.7. We have our dependencies here. Yeah. Let's do compile. So this is the source and the test resources. Clean first. If this works, then you need to explain why cleaning matters here. This does not work. So here's GLFW sys. So the jar is found here. And here's imgui sys. So the jars are found. I did a local install of the line jank plugin right before we got started with this. So I have the 0.7 version installed locally. This could be the middleware problem of the jank build not ending up inside that we just changed. That's a good theory. Yeah. So the build script doesn't make it in. And that build script we got from, or we tried to get from updating the verbatim paths here. But apparently that doesn't cut it. This is not an issue with concat. because that'll give us a sequence. This is still spelled the same. This is jank-build.bb. This is running before the verbatim file specs. So verbatim paths here is a sequence. File specs is empty. What do you see? Oh, we're passing the original project into, I see. Okay. So let's do project here, and get this like so, and then here, let's replace this with project. That should be fine. Still don't have it. We take our default project, we deep merge, we update, that gives us a new project. We take that, that's what we use for this. We end up calling this twice. We call it here, and we call it again here. And we're updating the file specs. Where are the file specs? There are no file specs. Yeah, so all we do is concat both times. So even if we called it twice, we would just have duplicates. And we don't clear out the verbatim either. So the second time we call it, we should still get all the same values. Not currently seeing it. But yeah, both times. Oh, well, I'm printing it before. Whoops. It says could not find project.clj, which is needed for install. So we fucked something up. Oh, because I didn't return the project. That would be why. Mm-hmm. Here are the file specs. Was I just not returning the project before? I swear I was, right? I absolutely was. Not there. Well, we do have the file specs here, but the second time around, we also have the file specs. This is a function. File specs are a function. Okay. So let's, so we have file specs. Basically the main issue here is no dependency built when running, compiling imgui project with 2 sysdeps. And then juggling of source build, outbuild, descriptors. You need to do line jar maybe? Not normally. Normally an install does everything that's needed. Oh, I'm sorry. I've been installing the GLFW sys and then taking a look at the imgui sys jar. My bad, my bad. Okay. I mean, there was a bug, and you know, and we found the bug. The bug was that we were passing the original project into the verbatim file specs thing. But I also was fucking up with how I was testing it. And so once we did succeed in fixing the bug, we didn't realize. Okay, so now we try to compile GLFW sys and imgui sys. GLFW sys works. We get the three things we want. imgui sys get a failure because, and then also that was not, it's not something we need to worry about. Not a directory. Is that going to work fine with submodules? Is there anything we need to worry about for that? So we have imgui sys. We need verbatim paths, and this is libimgui. Line install here. And then I need the make file in there as well. Yeah, that make file. Okay, so now we just have linker errors to OpenGL. And that makes total sense because we just need to update our normal stuff. Yeah, so in terms of UX here, I think it would be very helpful to be able to visualize better the directories that we're working with. And maybe in terms of simple wins, what we can get out of this is I'm just wondering if there's something that we can do with the tree command, or like our own sort of implementation of the tree command, where we basically show the trees of, honestly, there are a bunch of trees that are interesting here for somebody who's writing like one of these packages and dealing with what's going on. There's the tree of the jar. So when I do a line install, like maybe we have a way to just say it's installed and then also print out the tree of the jar. Like maybe that's a useful thing. But then also when you're working with the jank build script, being able to visualize the source dir, the build dir, the out dir, and what each of them has, that might be really helpful as well, especially when you go to like copy from one directory to another. Sometimes it's tough to get, you can end up with like off by ones where you copy foo into bar, and what you really wanted was to copy everything in foo to everything, into bar. But what you ended up copying was foo itself. So that way you have bar/foo. Whoop, close my eyes to visualize. Then I just end up slam my hands into everything. And printing trees, for me, is like the way I generally visualize that. It's nice and structured, and easy to grasp. Maybe we want some way to make that easier for people. Spirit 128, welcome to the stream. I hope you're doing great. Thanks for joining us to our travels. You can see the directories in target 2, but not the build dir since it's temporary in the sandbox. Yeah. Yes, I think I need to chew on this. All of the pieces for this are here, and it feels so good to see them come together. But the UX of writing these packages, we can improve it. Maybe it's as simple as having some functions that are like debug functions. Like maybe if we have like a jank build debug namespace, and then that just has some print functions to like, or even a print function to just print out the contents of directories and jars and stuff. Maybe that's useful. And then somebody would just be able to, as they're writing these things, more easily just print that out. That way they don't have to go find the temp directory and, manually go do an ls in there or something like that, because that's going to be different every single run. See the example, which see make helper dependency in jank sys, jank JSON sys. Mm-hmm. Yeah, this is like a really nice helper, right? This is so much better than what we had to do, right? This is the sort of thing that we want to strive for, and the fact that we're doing this with a make file that does an in-source build certainly makes all this harder. So maybe it's not as as much of a concern. I don't know yet. I guess we're gonna have to see what people are running into. Okay, so we libraries, we need to link to GL. It's uppercase, isn't it? Of course it's fucking uppercase. I swear it was. Let me jump to all right, let's jank readme. It is. Yeah, I think I'll need to get that. Let's see, you don't have a flake here. I'll need to find how to get, let's see. So I want to do, can I do just, yeah. I doubt this. I doubt this will work. Oh, nice. I was imagining it would just have to come through Mesa or something. But now I'm... yeah, and now we just have to deal with Nick's issues. So one thing I can do is I can just... I'll just go here. So maybe we go into our flake and we add some tools here. So we were using GLFW and we were using package config. And we'll try libgl and we'll see if that works. So let's get back into here. So I think we'll need to do some... let's see if there's a wiki entry or something for this. Oh, that's helpful. That's actually all you need to say, because I think it's this. So jank has an issue where where Clang is automatically looking in user lib and then this this host triplet, and jank is not. And I think that's the problem. So link libraries. Fuck. So let me take a look at this guy. Yeah, we can try that. I see. So what we really need, what you're really saying, Kyle, is we need a GLSys package. Because clearly we can't just rely on finding it globally. And we have to have these specific include and linker flags in order to find it. Don't shoot the messenger. No, man. Well, we happen to have this really this really new way of doing things that allows us to see him. GLSys. Oh, you know what? I copied the wrong one. I want to copy the GLFW. So for this one, we'll do that. And this one, this is just this, really. Should be it. Yep. And those are, oh, we gotta watch out for that. Is that duplicated? Is that why? Ah, it is. Ah, geocaps. I would have found that eventually. Okay. Now we need to add that to our project. GLSys. And then we don't need to worry about this. And we don't need to worry about this. And we don't need to worry about this. Damn. And we only built GLSys because we'd already built the others. And so if we do this, we don't build anything. Damn. Okay. Now can we actually can we actually do some like imgui shit? Can I just yoink what you have? What's this demo? That's a bunch of stuff. Does this use the, this doesn't use the demo? No, this doesn't use the demo. Yeah, let's do this. Yoink. And source main. Does this have a main? No. Oh, that's because the demo probably does that. Oh, sorry, black screen. Demo has main. Yeah, demo has main, and then run app. How much do we need? So you have all this set up for like repliing. Maybe we start with all this because we know it works and then we trim it down. Also, we don't need this stuff anymore. We could do include and let's do oh, those shouldn't be wrapped in parens. Whoops. Get rid of everything in imgui demo except like label and the app function. Yeah, because you have like eval and a bunch of other shit. Okay, so we don't find the backend. And I think that's because we didn't add the backend directory to the package. Yeah, so we want another one here for backend. Backends. Install So here is this. Mm-hmm. I don't see the backends added here. I went into imgui. Okay. So this seems like I did that right? Okay. Okay, so it doesn't find libimgui.so. Is this because we don't actually block on this, and that I thought that the sh is a helper that blocks. Sh is a helper that blocks. Blocks automatically. So it's not a problem with that. This builder is apparently temp jank build. This doesn't look like the correct builder. Is package config still in my shell? Maybe not. It is. I'll go in there and try to make so make works in this shell. But this builder is odd because shouldn't this be a builder that is named based on the current package or something? Try line compile in imgui sys. Sure. Lib imgui sys. It's always temp jank build. Well, then how? We can't do that. Because how can you be building two things at the same time? They're going to conflict with each other. Okay, so that's an issue. So line jank builder can't be temp jank build. Need to support parallel builds. We don't build in parallel. Oh no, we don't build in parallel for one project right now, but on the same operating system, somebody might be running line compile, for two different projects at the same time. Imagine you have a build server that is that's compiling jank projects for somebody, If you, oh, okay. So yeah, it's because I don't have the bubble wrap that ends up being a problem. Got it. Okay, so if we're in this directory and we do a line compile, we end up with the same problem where this is not found. Oh, I do have bubble wrap. I didn't install it. Maybe it's in the flake. Yeah, it's in the flake. Yeah, I mean, if you're using bubble wrap, then and that path ends up actually being unique, then no problem. But if you're not, then that ends up being a problem because that's just a global well-known directory that two places could be writing into. So I'll make a note that that's only a problem without bubble wrap. But so if I do a make here, and I wonder if this is what happened before. Did I do a make and then a line compile? And so then it found the file. No, it's not. Okay. What did I break here? So we're copying from the build directory, build lib imgui.so, right here, build lib imgui.so. That's right. Build lib imgui.so goes into out directory. And we do a make in the build directory. But the problem is that the build directory, oh, I can't look at it here because it's in, that's in bubble wrap. Yeah. Watch, and then it works. Oh no. And then, yeah, we see all of our files here. Okay. What is that? Oh, that's a follower goal. All right. I don't know why it just announced a follower goal now when we don't have any new followers in the past while, but congrats everyone. Goal achieved. Yeah, I don't I am not going to worry about this right now. As you said, I'll ignore the sandbox for now. So okay. So this is fine because this is just because we need to do this. Oh wait, what was that? So I think that this is an AOT bug, that we just don't set up the R path correctly for AOT binaries to find dynamically linked dependencies. So I don't think that that is an issue with the build system. Let's try a line run. Right. I could. Okay, line run does not work. The LD library path is equal to target and debug, and then we want this is for imgui. So imgui sys. I don't actually know which one of these it is, but it really doesn't matter because it's going to be the same binary anyway. Out. Thank you. Oh, one is source and one is out. Gotcha. It feels a little nixy. If I'm not gonna lie. Oh. We did it. Oh man, I'm tired. We did it. Yeah, this is it's promising. It's promising, but we found a number of issues. So our path not set up for shared lib deps on AOT binary. Nice. Nice. All right. So I am going to fill out these examples. So I'm going to trim down this imgui example a little more if I can, because there is quite a bit of code remaining in these two files. Ideally, we can just bring all of this into one file, because for a demo, you just don't need to have both. But that is, yeah, line run did not work. You're right. I need to note that as a bug as well. I saw it flicker. Yeah, exactly. I saw a flicker of a window and then a crash. So line run crashes with imgui example. AOT works with yeah. Nice. So I'll trim these down and then I'll get them documented with readmes as well as comments throughout, and then I will go through and start fixing all these bugs, because like these things that we were working through today, like if I hit them is I was trying to write like normal. Also this wasn't actually a bug. But if I hit these while just doing normal stuff, then understandably everyone else is going to hit them when they try to do stuff too. So these are at this point now my my highest priority stuff to work on top of the distribution stuff I've been doing to make sure that we have working binary packages on Arch and modern Ubuntu versions and everything like that. But yeah, this was incredibly helpful. And Kyle, I would have not been able to get this imgui example working in this stream without all of that pair programming. So thank you. And thank you for building this amazing build system that we have now that allows us to have an example with three native sys dependencies, each with their own custom build scripts that are all feeding up into jank. Like, this thing works, man. That's so cool to put together on my end. It feels very cargo-like, you know? And sure, it's rough as we're trying to build this out, but as we fix these issues, there was also an issue where I needed to line clean at one point to get new depth, and I don't know what's up with that, but yeah, this is great, man. This is so exciting. It feels really good. I think if we could address some of these issues, and then if we can implement, more and more of these packages, so that we'll have like a GLSys up there for people to use. When I'm looking through the results of these survey that I put out yesterday coming in, and a lot of people are interested in game dev. So I think getting these sorts of packages, just making it easy for people to spin up OpenGL windows and whatnot is really gonna help, and with this build system and everything, we're getting there. We're on the road. We're moving. All right, I'm gonna call it. That was tiring for me. Kyle, that must have been tiring for you. I appreciate you, man. Everyone, I'll try to get these worked on, and I will catch you next week at the same time. Thanks for hanging out. Adios.